the question that you gave in the MCQ means the assignment
Yes.
quiz. In that the means the last question that you gave, for which quantities can we find out influence line diagram?
Huh,
That
huh.
answer is not properly given.
Which
Understand by
quantities means, see, for what, which structural quantities actually you are finding influence line diagram for bending moment, shear force, deflection, and reaction. Okay, support reaction. So all these things you should mention there. Okay, in that answer. Is it okay?
okay.
Quantities means.
I
Huh.
I write this answer, but I am confused that
Hmm.
this is the correct one.
No, no, that is correct. Yes, yes. Those are the quantities for which you can find out influence line. Basically, see, whatever the structural parameter, structural analysis giving you, means after the analysis of the structure, what are the whatever the things you are finding out for every quantity or for every function, you can find out the influence line diagram. So what are the ultimate output of any structural analysis? Ultimate output of any structural analysis, if you see, those are nothing but bending moments, shear force,
Yeah,
internal
tension,
reactions, external
deflection.
reactions, deflections, all these things, right? So those are the quantities. Is it okay?
Thank you.
Okay.
Thank you.
Yeah. Okay. Let us start today. Let us start today with the second part, whatever we were discussing, that is this one. This problem we started yesterday, but we could not complete it because lot of disturbance were coming on in the previous class. Okay, so let us start with this discussion. Construct the influence line for the vertical reaction at A of the beam. So you can see the beam is AB, so it's a simple supported beam, length is 10 meter. What you'll have to do, you'll have to find out the influence line for reaction. So in this case, the quantity for which you need to find out influence line, the reaction at A. So what you'll have to do, first step for influence line diagram, what I said, you will have to move a unit load along the beam. So you will have to move one unit load along the beam, and for every position of that unit load, you will have to find out what is the reaction at A, and for different positions of the load, whatever is the reaction at A, that you need to plot it in a diagram, and finally the diagram whatever you will get, that will be the influence line diagram for reaction at A. Now in the previous class I was just showing you this one. So you see, what you'll have to do, you'll have to pass on a load of unit quantity. You'll have to pass on a load of unit quantity. So let's say, let us take this example through this one. I'll just try to show you. So can you see this Word document? Can you see this blank page, white page, everyone?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yeah. So let's say I have a beam. So what is the beam? Let's say this is the beam. Everyone can see this one, blue line, or I need to make it little
Yes,
bit.
Yes, sir.
हाँ दिख रहा है?
Yes, sir.
Okay. Now you see,
Yes.
this is a simple supported beam, and the simple supported beam, for the simple supported beam, what you get? You get two reactions, right? Sorry, not this way. Two reactions. So I'll just insert two reactions. So basically there are two reactions. One reaction is over here, one vertical reaction is over here, and another reaction is at here. Okay. So this is your point A, and this is your point B. So actually you see, whatever the structure you are taking, if you idealize the structure, then what you are getting? You are getting actually a structure something like this. If you are idealizing it, then you are getting a structure something like this, where you say this is actually your this is actually your A, this is your point A. So this point is your A, and the other point other point you see here it is B, right? So what is to be done? You will have to find out the influence line diagram for the reaction at A. So let's say the reaction at A is RA, okay? So RA, I am just writing it within a bracket, okay, or I can do superscript subscript also. So let's do the superscript subscript only. So let's say RA, and the reaction at A is basically RA, and you see the reaction at B will be RB, okay? So reaction at B will be RB. Now if you want to find out the influence line diagram for this, then what you will have to do? You will have to pass one unit load throughout the beam. And when we talk about the unit load, you see the unit load will be of dimensionless quantity, okay? So you need not to think about whether 1 kilonewton load or 1 kg load, 1 pound load, just one unit load will pass on. So let's say if I first, let's say my load, let's say my load, the whatever load you want to pass, that is a unit load, and this is your unit load, let's say, and let's mark it as you load with some other color, so it will be better to understand. Let's say this is your load, and the line color, let us make it as red, okay? So if we do it, then you see when this load is outside the beam, let's say that this load is moving like this, and if the load is outside the beam, will there be any reaction coming at RA and RB? If there is no load on this beam, will there be any reaction at RA and RB? Any answer?
No, sir, no.
No reaction. Okay.
No, sir.
So see, the first time the reaction will come when this load will move like this, it will move like this, it will move like this, and then it will reach the support. Exactly the support point when it will reach, at that time it will have some reaction, isn't it? So you tell me now, if this value of this load is equal to 1, so if the value of this load is equal to 1, so if I take this as unit load, so if the load value is 1, then you tell me what will be the reaction at A, that means what will be the value of RA because of the position of the load just above the support A. How do I get it? I will get it using this concept, right? I will be getting it using the concept that so what I will be doing, I am just writing it above. Okay, so how will you be getting reaction at RA? You will have to take moment about B. So if you take moment of all the forces, about B, then what will happen? So according to the equilibrium equation, summation of all the moments, so sum of all the moments should be equal to 0 about B. So sum of all the moments about B should be equal to 0. Okay, so if you want to take the sum of all the moments equal B is equal to 0, then what will be the equation coming? So the equation, you see, the equation will be coming like this. It will be RA, control V, RA multiplied by how much? What is the length of this beam? 10 meter, right? The length of the beam is 10 meter, right? So RA into, I am taking moment about this point B, so RA into 10. So this if it is if this is your clockwise moment, then this one will be your this force will be creating moment about B is anti-clockwise. So one, if you take positive, the other one will be negative, so then it will be minus of 1 into how much? 10. So it is going to be equal to 0. So what will be the value of RA then? So the value of RA in that case will be equal to, RA will be equal to, control V, RA will be equal to, this is going to be equal to how much? Tell me. 10 divided by 10, it is going to be equal to 1. Is it clear? Is it clear to everyone?
Yes, sir.
Yes, sir.
Okay. Now see what is influence line. So when you are finding out influence line, what will happen to this load? This load will be moving over the beam, right? This will be moving over the beam. So at every point, actually what you should do at every point, so after 0 position, so if I take this as 0 position, then after that I need to move this load from some position here, some position here, some position here. So the load needs to be moved. So let's say, let us move it by quarter length. That means 1/4 of 10 is how much? 2.5. So let us say, let us move this load, this unit load by another one amount. This length basically. So what we are saying, the length from here to here, the length from here to here, so the length from here to here, this is actually how much? How much we are saying? 2.5. Okay, 2.5 meter. Clear? So how much will be the length from here to here? Can anyone tell? Tell me fast. So how much will be the length from here to here? Tell me.
7.5.
7.5. Yes. So from here to here, if I take, then the length will be 7.5 meter, right? So you see, so let's say this load is moving, so initially the load was here. So see, the load will be going to this position, gradually it will be moving, and let's say it will come to some position as 2.5 meter, and at that point again let us try to find out what is the value of reaction. Okay, so if you want to find out the value of reaction, then how do you find out? So what will be the value of reaction? So let us take this equation again and let us try to find out what is the reaction. So what will be the reaction value? Tell me. RA into 10 will be there. So this much length is 10 meter. Is it clear? RA into 10 meter, because RA 2.5 plus 7.5, so 10 meter, and this one load now has been moved by 2.5 meters. So the moment about B, when you will be taking, this portion will be changing to how much? 7.5. Is it clear to everyone? Why it is 7.5? Have you understood?
Yes, sir.
So
Yes,
now
sir.
you see the value of RA. So the value of RA, you see, will become how much? It will become 0.75. Is it clear now? So you see, because of the two positions of the load, one first the load when is just on the support, and one the load when it is just at the 2.5 meter distance from the support, we have found out, because of the changed position of the load, what are the reactions at the support. Now I'll have to, what we'll have to do, we'll have to move this load throughout the beam. So let us say, let us take this load to the middle position of the beam in the next case. So if I take it to the 5 meter distance, so let us say if I take this to the 5 meter distance, that means I am making it this and this equal. So let's say this is going to be 5 meter, and this one is going to be again 5 meter. So 5 meter and 5 meter. So just the reaction, the load, unit load has come to a position. Please understand, this load is unit. Okay, so this load has come to a position at the middle because of the movement. Okay, so at this point, what will be your reaction at RA? So when this load has moved by this amount, what will be the reaction at RA? So you say RA into 10 is going to remain same again, it is not going to change, and you see this load has moved by 5 meter from this support. So if you want to take the moment about point B, this is going to be equal to 1 multiplied by 5. So that is going to be equal to 0.5, isn't it? Sorry, 0.5. Is it clear to everyone? These 3 steps, have you understood clearly? Okay.
Yes, sir. Yes, sir.
Now you see the load will move further. So how long will you have to carry on this activity? That is the question. Okay. So you will have to carry on this activity until the load is moving out of this beam. So let us say let us move another 2.5 meter this direction. So let's say we are just moving this load by another 2.5 meter. So again this one is now the load is being positioned somewhere here, which is nothing but your 7.5 meter, and on this case it is becoming 2.5 meter. Okay. So if this is the case, then you see if this 2.5 meter is the distance of the load from the support B, then again you can find out the reaction. So how much will be the reaction in that case? So this equation will change. RA into 10 will remain same, and then 1 this unit load is going to have a moment about this point B, which you need to multiply with, you say now it's 2.5. So your RA is going to be equal to 0.25. Is it okay? Next step.
Yes, sir.
So next step, you see, next step your load will move further, it will move further, and it will reach the support, let's say. So let us remove this and let us remove this. So what is happening? This load is now being moved by an amount, another 2.5 meter, and the load is being placed over here. Okay, so just on the support B. Now in that case, if you want to find out the reaction, so there will not be any moment of this force about this RB, right? So what will happen to this equation? If you want to take the moment about B, you see the equation will be changing to RA into 10. So RA into 10 will remain same, and then you have unit load which is just placed over the support B. So the distance of this unit load from the support B will become equal to 0. So you see your RA value is going to be equal to 0. Have you understood this thing? So what we have done exactly? What is the difference between influence line and bending moment diagram? Shear force, bending moment, or reaction calculation? You understood? In case of reaction finding for a fixed kind of load, you will have to do this activity just only once, but in this case you see multiple times you need to find it out, and you see after this there is no other way the load will move out of this beam, so you will not have any reaction. Okay. So now if you plot this reaction quantity, RA, so that is what is the quantity I have mentioned in the question, the quiz I have given. So if you want to find out the influence line diagram of reaction at A, then how do you find it out? See, it's very simple now. So you will have to find it out this way. So you see, you are having this length of the beam is this much, so 10 meter length, and you see at 0 distance, when the load has just entered, and when the load it has just A, at the 0 distance, you see you had a amount of this thing as 1. So this value is 1. When you are reaching a 2.5 meter distance, let's say you have a value of 7.75. Okay. When you are reaching, this is 0.75. When you are reaching a distance 0.5, then you see, 5 meter, then you see you are having a value of 0.5. You are having a value of 0.5. When you are reaching distance 2.5 meter from the support B, then you see you are having a value of 0.25 like this. Okay. So you see if you are getting these values and if you want to try, if you want to find out the influence line, what you will have to do, you will have to join these points with something, okay, and if you join the points with something, then you will find out that it will be joined using a straight line. So basically you see, this is actually is going to give you the influence line diagram. So basically if I write it over here, then actually this diagram will be called as influence line diagram for reaction at support A. Because you see, you will have to find out influence line diagram for a specified position, and in this case the specified position is the point A, and the quantity for which you want to find out the influence line diagram is the reaction at the specified position, that is A. So have you understood this concept? So you see, this way you will have to find out the influence line for every case. Like if you want to find out it for shear force, if you want to find it out for bending moment, if you want to find it out for deflection, all the cases ideally you will have to go by this step by step method. So you see, this step by step method is looking to be simple to understand. However, this step by step method may be very complex also, because multiple time calculations you will have to do, right? Multiple times calculation you will have to do. Instead of that, as I have mentioned in the previous class, if you remember, that influence lines can be represented as a function of x. X means, x is the distance from some point or distance from left end or right end of the support, okay. So if you want to find out that, then you see, you will have to take a variable quantity x, and for different values of x you should be very easily able to plot it. And when you take a value of x from some support and the x is a variable quantity, in such case what will happen, you will get a function in terms of x for the reaction at A. Let us try to see how it will happen, okay. So let us try to see, and we will see whether this influence line and the concept what we are specifying now, they will match or not. So let us try to see. So what we are saying, this unit load, again I am bringing it over here, okay. So unit load is just outside the beam. Now let us say this unit load is changing its position, right? So this unit load is changing its position along the axis of the beam. So the beam axis, if it is along the x axis, then you see what we can do, instead of this x meter, instead of this 7, what we can say, this thing we can say that load when it is entering the beam, it may be positioned at any variable position x. It may be positioned at any variable position x from this, okay. So if it is positioned at a variable position x, so you see the value of x will change and the load will move. So you see, I can say the value of x is 2.5 meter. So if it is 2.5 meter, I will get the influence value as this. When the value is 5 meter, I will be getting the value of x will, my value of x will increase, okay. So basically what we are saying, x is a variable along the axis of the beam. So let us say this x, at a x distance we are placing it, and x is a variable. So if we want to find out now the reaction, can anyone tell me how much will be the reaction force in terms of x? What should I write it? So if I take again the moment about B, so exactly the same we are doing moment about B. If we are taking, then what will be the value of X? Can anyone tell? So what will be the value of RA? So what should I do? RA into how much should I write? Bolo, moment about
10.
B if I do?
10.
RA into
10.
10. Yes. RA into 10. Then minus what should I do?
1 into 7.5.
1 into how
1
much
into
should
X.
I write? Tell
Will
me.
be 10 minus X.
Yes.
10 minus
10
X.
minus x. See, if this distance is x, then you see very easily you can find out, right? It's very easy to find out. So total length of the beam is 10 meter. So basically this distance will be how much? 10 minus x. Is it clear? So basically this one load is going to create a moment about B, where the lever arm for this moment will be 10 minus x. So it is going to be 10 minus x equal to 0. Oh, sorry, equal to 0. Now if I do it, so you see what I will get it from this. So from this you see what will be my value of RA. So tell me what will be the value of RA. RA is going to be, thus RA will be equal to how much?
10 minus x by 10.
Yes, absolutely correct.
Minus x
So
by
RA is going to be 10 minus x, 10 minus x by 10, right? So if I simplify more simplification if I do, then what will be the value of RA? What will be the value of RA? Let us say this one I am again I write here. So what will be the value of RA, you tell me. So RA is going to be 10 by 10 is going to be 1 minus x upon 10. Will it not be? Is it clear?
Yep.
So what
Yes,
you are
sir.
getting, you see the RA, this value, the reaction RA, now you are getting as a function of x. So what you are getting? So you see, you are representing, that means what you are representing this RA as a function of x. Sorry, as a function of x, correct? So for every value of x, you can find out what is the value of RA. And if you see this equation, what is this equation shows? Is this equation of parabola? Is this equation of ellipse? What is the equation shows? Tell me. What is the type of this equation? What is this form
Ellipse.
shows? Is this equation of parabola? Is this equation of
Ellipse, sir.
ellipse? Pardon?
Ellipse.
Pardon?
Ellipse, sir.
Ellipse. Is it?
It's a straight line.
It's a straight line,
Straight
simple
line.
straight line. You see, it's nothing but RA. If you think RA as your y, then it is nothing but y is equal to mx
Square.
plus c. See, this is your mx, and this is your c.
Minus mx decreasing.
Minus mx, yes, you can say minus mx plus c, nothing else, right? Is it clear? So see, this is actually equation of straight line, and that is what I have said in the previous class, if you remember. Okay, I'll go back to the slide and I'll show you again. So you see what we have said in the previous class, if you remember, this is what actually we have done. So the influence line can be constructed by placing the unit load at a variable position x, that's what we have done, on the member, and then computing the value of, you can compute any value, right? You can compute the value of R, V, M, delta at any point P, and in this case this point is A, as a function of x. And you see, in this way you will get some equation, and that's what we have got. We have got an equation, right? We have got an equation for this RA in terms of this variable x, and you will get some equation, and this equation will be consisting of various line segments. See, in this case, in this problem, you are only getting one line segment. However, you will be observing when you will be taking more complex problems, or when you will be taking the problems of shear force and bending moments, you will be observing the equations for straight lines will change. Okay, so you will be getting various line segments composing the influence line, which can be determined and plotted. Okay, now you see, now from this you can see it can be very easily plotted, and you, if you observe, if we plot this influence line diagram for reaction at A, it can be very easily plotted. And you see, what can I do? I can say at x equal to 0. So at x equal to 0, you see what will be the value of RA? What will be the value of RA? If I take at x equal to 0, what will be the value of RA? Can anyone tell?
1, sir.
1.
Sorry. It is going to be 1. Because if I put x equal to 0 over here, so 0 by 10 will become 0, then RA is going to be equal to 1, correct? Now you see, if you put all these values at different points, see, you are going to get these values from this equation. I will just show you with the verification. See, if you take at x equal to, we have calculated at a distance 2.5 meter, this is for 2.5 meter. So for this you have got ordinate 1. Now if I take at x equal to 2.5, you tell me what will be the value of RA? So 2.5 divided by 10, so how much it will be? So it is going to be 1 minus, I will just simplify and write it, 1 minus 2.5 by 10, which will be nothing but 1 minus 0.25, which is equal to 0.75. Are you getting this value and this value same? Are you getting it? So see, using this equation of straight line, you should be able to find out the influence of this unit load because of his change in position on the beam, and the quantity of reaction, how it will vary because of the movement of this load. So you see, if you go further, you see, you are going to get exactly the values. I will just show you. So you see, if I write it at x equal to 5, what will be the value? You see, at x equal to 5, this one will change to 5. So this is going to be 1 minus 5 by 10. It is going to be 1 minus 0.5. So how much will be the value? It will be equal to 0.5, isn't it? So see, this value and this value is matching, and this is the ordinate. So see, at every point what you are calculating using this equation, you are calculating basically the value of the ordinate of the influence line. And you notice, just at the end, if I go, so at x equal to 10 if you go, so what will be the value of RA? Your value of RA is going to be 1 minus 10 by 10, and 10 by 10 is going to be equal to 1, and that is going to give you 0. So at x equal to 10, that means when the load is just moving its position, and when the x is becoming this, so when the x is becoming equal to 10, you see the value of RA will be becoming equal to 0. And thus you see, with this equation of straight line, we should be very easily able to calculate or plot the diagram of the influence line. And you see, your diagram for the reaction at support A is not going to be changed at all. Have you understood this clearly, or there is some doubt? See, if you understand this concept, you can find out influence line diagram for any other quantities also, but it is very important to understand. Okay, so any doubt? If you have any question, please ask now. If you have any question, please ask, or otherwise I'll go forward. Let me collect the attendance at this time. Any question? Anyone?
No, sir.
No, no need to give attendance now. No need to give. Don't give it to the chat box. There is no need, because I have taken it. No problem. Okay. So should I go further? So you see this problem now I will show you over here. So you see this is the one we have discussed. So you see all these things I have explained in that Word document, if you notice. So please go through this problem solution. So in this problem, so what is being done, a unit load is placed on the beam at each selected point x, and the value of Ay, in this case I have taken this problem from R.C. Hibbelar's book. So in that case, the reaction instead of Ra, in that book it is being mentioned at Ay, so the quantities are mentioned like Ay, is calculated by summing the moments about B. That's what we have done it also. And you see you are going to get the diagram something like this. If you see, the diagram is something like this. We have got. So one is over here. So you see exactly the same equation we have got. And what is the equation? What is this equation of straight line? So the equation of this straight line, so if you see the equation, so the equation of this straight line, if you take, so this is going to be equal to 1 minus x by 10. So this straight line, actually this straight line will be the equation of this straight line will be 1 minus x by 10. Okay, and that is nothing but the equation of a straight line which is having a form y equal to mx minus mx plus c. So you have got an intercept of 1, and then gradually the slope is decreasing, and it will become 0 at this point. Is it clear? Okay. Now let us go to the next slide. You see, that's what we have shown it in this. So this is the one I have shown you using that Word document, step by step calculation I have shown you. And you see, if I position it at a distance x from some point, and you notice here, when we are writing that influence line diagram, you see we are not mentioning any unit. You notice over here we are not mentioning any unit, because you see the load, the point load you are placing on the beam, it is having the unit of 1, and it is basically a dimensionless quantity. So as it is a dimensionless quantity, while finding out the influence line diagram, you need not to be much worried about the dimension of the load. However, you should be cautiously taking the dimension of the length of the member, because you see the length of the member you will have to consider, because length of the member, if you take in some different units, then your influence line diagram plotting and the value of the equation whatever you will be deriving, that will not be correct. Okay, so with this concept, let us now move little forward and let us try to understand the next problem. So example number 2. So see, it says construct the influence line for the moment at point C of the beam. So how do you do it? So if you want to find out the influence line for the moment at point C, then you see what you will have to do. Again the same process you will have to take, right? So see, in this case the particular point, the point whatever is mentioned, if you remember, again you go back to the slide and you see in the definition what we have said, to construct the influence line as specified point P. So at a specified point P you want to find out the moment now. So in this problem, what is this specified point P? In this problem the specified point is C. So what you will have to do, you will have to find out the influence line diagram for the bending moment at point C for a simple supported beam of length 10 meter, where the C is a point which is located at the middle of the beam. See, the position of the C may change. So for every change in position of C, so for that every change in position of C, that specified point position will change, and when that specified point's position will change, your influence lines will also change. So you should be very clear about this fact that the influence line diagram for bending moment at a point C, which is at a distance of 5 meter, and at a point C, let's say, which is at a distance of 2.5 meter, will be completely different. You must understand this, because we are not talking about bending moment diagram, we are talking about influence line diagram of bending moment at a particular or at a specified point C. Now to solve this problem, how do you do it? You can take the same approach, as you have taken it earlier. So just like this problem, what you can do, you can step by step, what you can do, you can calculate the value of reactions, and then for every point you can go on calculating the moments, and thus you will be getting one moment diagram, right, or influence line diagram for the moment. But as you have observed, as you have noticed, that step by step if you want to calculate it, so the process becomes little bit cumbersome. Instead of that, if we can represent the moments also using the value of x, so the moment, if it can be represented by a function of x, then it will be very easy to get the influence line diagram for bending moment at C. Okay, now let's see how do you do it. So let us take the example. So this one if you notice, so you see, you will have to find out the influence line for bending moment at point C. Now if you remember, just 2 minutes back I was telling you about this line. You should go back and see this, that equation of the various line segments. So this will come in case of bending moment diagram, influence line diagram for bending moment about C. You will observe while solving this problem, you will not be having a single equation of straight line. Instead, you will be having multiple equation of straight lines. Now we will see how it will be multiple equations of straight line. So let us come to this problem and see. So I am not going to this one first, because this is a method where again if you will have to put the values and one by one you will have to calculate the values of bending moment. Instead of that, let us go to a method where you can solve the problem using the influence line equation. So we will be using this method primarily for finding out the influence line diagram. So influence line equation. Now influence line equation, whenever we will be talking about, so we will be seeing that. So I am removing it, okay. So we have finished it. Let's say again we are coming back to a problem something like this, and what is being said that it is a 10-meter beam, and you need to find out the influence line of bending moment for a specified point C, which is exactly at the middle point, right, which is exactly at the middle point of the structure. So it is somewhere here. You will have to find out the influence line at somewhere here, which is basically from this to this it is 5 meter, from this to this it is 5 meter. So at the middle point of the structure. So if you want to find it out, so what you will have to first do? So you will have to find out the bending moment for the point C. So how do you find out? To find out bending moment at any point, what is the first process? So to find out the bending moment at any point, what do you do first? You first find out the reaction, right? So first you will have to find out the reaction force. So let's say the load in this case again is coming and it is entering the beam, and it is moving, and it is moving at various positions, and it is reaching, and it is just getting out of the beam. So let's say we assume a particular position x of the load, and for that particular position x of the load, we will try to find out what will be the bending moment at point C. So if we want to find out the bending moment at point C, first step will be what? First step will be you need to find out the reaction at RA and RB. So what will be the reaction at RA? So this is going to be RA minus how much? Tell me. 1 into same 10 minus x equal to 0. So your RA is going to be equal to
10 minus x.
RA is going to be equal to how much? Tell me. 10 minus x upon 10, isn't it? So if you want to now find out the moment about C, then what will be the moment about C? You tell me.
Sir, RA into 1 you have written, sir.
Pardon?
RA into 1 you have written, sir.
Oh sorry, RA into 1 हो गया, correct, very good, rightly pointed out. It will be RA into 10, sorry, yes. So you see, now you see, if you want to find out the bending moment about C, then what you will have to find out? You will have to find out MC, right? So if you want to find out MC, then what will be your value of MC? So you see the MC value, which is nothing but the moment about C. How do you get it? You will have to take moment of this RA about this C. So how much is the distance of this RA to C? Tell me, how much is the distance of this RA to C?
5, sir.
What is the distance from here to here?
5.
5.
Five.
Absolutely correct. So this distance is 5 meter. So actually this is going to be your RA multiplied by 5, right? So this is, let's say, clockwise, okay? So you now take the sign convention. So what you will be doing? So if you are taking this one, as your clockwise as positive, anti-clockwise as negative, or anti-clockwise as positive, clockwise as negative, whatever you do, you will be getting the same way, right? So you see how much will be the moment about the point C, if you see. So moment about C is going to be equal to, you see, it is going to be, if you see this problem, if you see this solution, you will be getting it more clear. I will show it there also. So what you are doing moment of all the forces about C equal to 0. So you see this diagram, so you see this moment is this way. So this RA multiplied by this distance will come. So see, this is going to be clockwise, so clockwise is taken as negative. So here also we take clockwise as negative. So how much will be in this case? So RA value I will put it over here. So RA is how much? RA is nothing but 10 minus x, 10 minus x by 10, and this is going to be clockwise, so I will put a minus sign, and this needs to be multiplied with 5, isn't it? Okay, and then this one force is also going to create a moment about it, and this is going to create an anti-clockwise moment. And if we take anti-clockwise moment as positive, then you see what I'll do, I'll take plus. Okay, I'll take plus. What will happen? 1 minus 1 into how much it will be? Bolo? 1 into what will be this distance from here to here? If I take moment about C,
5 minus 6.
Bolo? Tell me.
5
Yes.
5 minus x.
5 minus x. Yes. Correct. So 5 minus x, isn't it? So see, I go back here. So see, we have got it. We have got this. So see, MC is going to be thus MC, and then what you will have to do? So you are taking summation of MC. So basically you will have to put a plus sign over here. So you see, MC minus of this plus of this, that is going to be equal to 0, because you are taking sum of all the moments about C is equal to 0. So if you do this, then you see what will be the value of MC. So if you simplify this equation, you are going to get the value of MC, right? So what will be the value of MC? If you simplify this, what will be the value of MC? Tell me. So if you simplify this equation, and if you go on the take this value on the other side, so you see your MC value is going to be equal to how much? Bolo, simplify karo. Tell me. So what should I do? So 10 by 10. So 10 by 10 means what? 1 minus x by 10 into 5 plus or minus 1 into 5 minus x. Will it be like this? Will it be like this or not?
Yes.
So you see, if you simplify it further, what will happen? So 5 minus x by 10 into 5, so 5 into 10 cancels out, it will be x by 2 minus of 5 plus of x. Is it clear? Is it clear?
Yes, sir.
Just algebraic simplification of this I have done. Okay, so how much it will be? So see, this 5 and this 5 will cancel out, and this plus x and this minus x by 2 is going to give you equal to x upon 2. And you see, if you see this solution, how much you are getting? MC is equal to x upon 2. Have you understood this? Everyone is clear about this or not?
Yes, sir.
Okay. So if you see, you have found out this MC equal to x upon 2. So exactly what I am getting, we are getting MC equal to x upon 2. So you see what you have got. you have got the value of moment about C at a particular specified point, for which you need to find out the influence line diagram for the bending moment that is being represented as a function of x. And you notice, what is this equation? This equation is again a equation, is an equation of straight line, isn't it? It is just y equal to mx. There is no c term in this, right? So you have just got an equation of straight line. Okay. Now you very clearly understand this. This is very important. Okay. So you see, this equation of MC will be valid for particular distance, because you see, this load, when it enters over here and when it moves and until it is just at the left of this point C, just at the left of this point C, till this point this equation will be valid. As soon as this load will be crossing, this, then your MC equation will change. And that is the concept of bending moment you have understood in your strength of material course also. Okay. So you see, this equation of MC will be valid, it will be valid only for x values, it will be valid only for x values where x is less or equal to 0, sorry, it will be valid only for x where x is less or equal to 0 and just little bit less than 5. You see, just little bit less than 5. That means just when it is entering 5, up to this point only, this equation will be valid. Oh, sorry. So just when it is entering this 5, up to that distance only it will be valid. So you see, from this MC equation, you see it is valid, this MC equal to half x, it is valid for x is less or equal to 0 and less than 5 meter. Beyond this, you will have to find out another one equation of MC. Okay, and that is what is being mentioned over here, that is what is being mentioned in this theoretical concept, as I have said here. Again I am showing you. In this way, the equations for various line segments, see, in this case you cannot go with one line segment, you will have to develop another one equation of line segment for another part of the beam. Okay. So I think let us stop here today, already it is 1 hour almost, or should I continue? So can you try this part for the next part? So what will be the just I will get the I will give the concept and then we will stop. So when you see, when this one load will be just moving out of this, when we just moving out of this, then you see what will happen to this, what will happen to this, this will become this, right, and this x will become this. Now will there be any change of your RA? Can you tell me, will there be any change of RA for the second case? Tell me fast. Will this equation is going to change when this load will come here?
No, sir.
It will not change, right? Because you see, you have just changed the position of the load x. What you have done, you have crossed this load beyond this point C. You have just done the change position of the load. Okay, but your point C is remaining here, so your x is remaining here. So you see, if you want to find out RA is going to be equal to RA into 10 multiplied by 1 minus 10 into x, 1 into 10 minus x. So your RA is not going to change, your RA is not going to change. However, you see, your moment equation will going to change, because you see, in this case what will happen, when you will be finding out your MC, you see there will not be any load on this, there will not be any load on this. When you will be taking moment about this MC, you see the load has already left this point C. It has already left this point C. So for the portion where x is less than 5 meter, that means or x is just little bit more than 5 meter and greater or equal to 10 meter. So you see, if I want to write an equation for this where x is, here it is, instead of 0 it is 5 and it is greater or equal to less or equal to 10. So for this case, you see, for this case, what will happen for this case? Oh, I think I am writing this position wrong. Here it should be here. Okay, that is why it should be written over here. Okay, so see, x is less or equal to 5, 10. For this, what will be the value of MC? See, only the load which will be acting to calculate the moment of MC will be this RA, because you see, this 1 kilonewton load already has left this position, okay. So if you want to find out this, then you see what will be the reaction, what will be the moment. So in that case, you see, MC will be equal to MC minus, just you see, there will be a minus sign because this load is going to create anti-clockwise a clockwise reaction. So this part will again come, and this will be equal to 0. See, there will not be any term of this one in this equation. Why? Because this one load has already left this position C, and it is moving out of this position C. So while calculating, this is the bending moment concept, this is nothing new, this is the bending moment concept, okay. So just left of the section and just right of the section. If you think this, if you see this free body diagram, you will be more clear on this. So you see, you are taking moment about this point, C, when the load has already left this point C. So this point, the moment of this unit load, you need not to consider while taking moment about this point C, and that's why there are two different equations you will be getting, and from this, you see, you are going to get an equation where MC will be equal to MC. So what will be the equation of MC? MC is going to be equal to, tell me, what will be the equation? 1 minus x upon 2, right? 1 or 5 minus x upon 2, 1 minus or 5 minus, 10, 5 to the 10, 5 minus x upon 2, 10 by 10 or 5 to the 10, so 10 by 2, that means 5, and x by 2. So 5 minus x by 2. So you see what you are getting. You are getting two different equations. One equation is valid up to 0 meter length, that means from here to this just left of this 5, and the other equation is valid beyond this. Other equation is valid, which is this one is valid beyond this 5 meter length, and it will be valid up to this 10 meter length. So actually what you will get two separate equations of straight line, and you will have to plot your influence line using these two separate equations of straight line. So in the next class, we will be discussing how to plot these different equations of straight line. Okay, is it clear? So if you have any question, please ask. Have you understood it?
Yes, sir.
So
Yes, sir.
So I'll today's quiz I will give one question. Okay, I will give a question that you find out. See, we have found out the influence line of reaction of a support about support reaction at A. Now I will give you a question to find out the influence line for support reaction at B. So you just calculate the values and you write the different values of influence line at x equal to 0, x equal to 0.5, x equal to 2.5, x equal to 10. Okay, I will give that question in your assignment or that quiz. Okay, so you just try to work out what will be the influence line for reaction at B, support B, and this moment thing, how to plot this moment equation we will be discussing in our next class. Okay, so how to plot this triangle we will be discussing in the next class. Okay, okay, thank you very much. Okay, chalo, we are